This video is about my experience with Hobby King Alien 560 Quadcopter and what lessons I learned from my first build. This video covers the second build. It started in a box from Hobby King. 560 is the size. It's 560mm centre to centre diagonally across the motor spindles. Can I start by saying I think it is an excellent design. I really like it. Having said that, there are some serious issues with strength. The first problem is the landing legs. There are various YouTube reports on the poor strength of these legs. Here is the standard one, far too long and very thin at just 1mm. The first thing I did was decide I didn't want them that long, so I cut them down, made them a bit smaller. Still the same material though, and as you can see, these didn't last long either. So I had this custom design machined. They are 110mm long, so they are a little bit longer than the original cut down ones, but you can see by the thickness that they are a lot thicker. These are 2mm. The ones I've got fitted here are actually 3mm, but 2mm is pretty good. These legs and a stronger deck that I will come to later, I've got available on eBay if anyone is interested in them. I call these A560SS. They are the only 560 super strength parts, so searching eBay for A560SS will find them. Whilst on the subject of strength, this is the standard lower deck as supplied by Hobby King, and as you can see, it has had a bit of damage. Not good at all here. The mount screw holes pulled through. This kit is advertised by Hobby King as a carbon fibre frame, but if you look at this material, you can see that it is in fact laminate. I believe it is glass fibre based with a very thin carbon layer top and bottom for just cosmetic purposes. This white colour you can see here, and also on the edges here, I'm told by a man who knows about carbon fibre, this is what is known as composite. The carbon fibre part that I supply under the A560SS range are 100% carbon fibre, and if that sounds like a commercial plug, then it probably is. And this is my thicker carbon fibre material for the lower deck, which is 100% pure carbon fibre. This one is 1.5mm. I originally had one machined at 2.5mm and it was okay, but I just had a feeling it was a bit too stiff, and the amount of flex needed for when you put these arms in and out of the clips was probably not enough, so I have settled on the 1.5mm. Right, now let's get back to the frame. The reason I like this design is because it has two decks, and as such I have chosen to separate them out on the build. You can see from the top deck here, which I will come back to in more detail later, I've got my electronics. The NASA controller, its power supply underneath, I've got my video transmitter, the OSD, the on-screen display, the DJI Bluetooth unit, and lastly the GPS antenna and LED on a custom mount. So let's take that away and we can just see this gives minimal connections to the lower deck. So to the lower section, let's start in detail and go back to the legs. You'll see that I have got the spacers at the bottom for rigidity. I've used some nice pretty red spacers, as I think they look better than the standard shiny aluminium ones. Also, I've increased the thread size up to M2.5. The originals were only M2s. The motors are Emax 3515s at 650 kV. Really nicely built, really powerful. We'll come back to the specs later. Turning again to strength issues, the standard supplied black fixings for these clamps and the pivots here. And just drop that down a bit so you can see. These are just not strong enough. I've had a few breakages after a couple of flights, though I should probably say crashes. Take those away and replace them with the Tower ones, which are available from Banggood, Tower's own website, and various other suppliers. These have proved to be a lot stronger. As regards to power distribution, I have designed and made available a custom PDB for the Alien 560. Let's have a look at a better photo of that. It's all a bit cluttered in here. On this board you can see there are places for two power inputs which are sized to take the XT60 plugs, which can be mounted top or bottom. If bottom, they protrude through the frame holes, or you can add wires to them, which you'll see on my model is what I have done. There are the solder pads for the 4 SCs, and it also has 3 auxiliary ports to give 5 volts and 12 volts, rectified at 3 and 2 amps respectively. These regulators are sealed with APL for weather protection, and this is the kit you will get if you buy with all the fixings, 5 12-volt connectors. You will see I have chosen BL Heli 30 amp opto ESCs. I chose the optos because there are plenty of regulated 4-volt supplies available, and I believe there is less chance of interference in the power and signal lines with these optos. Zooming back out from here to see the receiver antenna mount, I've got the 90 degrees tubed version, which we will have a look at when I tip it over. If we come round to the front of the frame and just by the middle, I have actually got 2 battery connectors here. I've got a big XT90 because that one is the main battery. I use a 4S 10,000 milliamp hour. I've also got a big, I've also got tucked down there a little XT60, so if I need to revert to a smaller battery when I'm flying one day, I can. I also plan to use this as a power out for a clip-on floodlight when needed. Let's pop round to the front. I've got my 2 front ESCs fitted here. I've also got this RC controlled switch. This started as a standard Pyramid Products part. Every time I flick a transmitter switch, I use a spring bias toggle. It steps through 4 different outputs which I'm using for my lights. I have front lights and side navigation lights. I have it set so that each step will bring in another light combination. I have had to make a few modifications to this unit. As standard, it will only output the 5 volts it gets from your receiver input supply, which limits the voltage and current you can use for the switched item. So I've modified this board so that I can choose whatever voltage, either LiPo or 12 volts, etc. I want for the accessory I'm switching. So if you are using one of these things, don't follow my wiring here, because mine is slightly different. Though with this picture quality you probably can't see how I've got it wired anyway. As regards lighting, I have fitted side navigation lights. I'll turn them on later so that you can see, but on the left port side I have these which are green when they are lit. 2 groups of 4 nicely spaced out which fit into the side frame that's standard with the Alien 560. And on the other side I've got exactly the same, but those are in red, because that's on the right, the starboard side. For the front lighting, which is still a work in progress, I have taken these, which you'll probably have seen in Hobby King or Radio C. These are rated at 3 watts, I have got 2 white on the outside and 2 blue on the inside. I'm running them quite high at about 900 milliamps, which on a 14.8 volt battery is 13 watts in total. They are quite bright. They run hot, probably at the limit of the aluminium plate. But there is a bit of air cooling from the props, I suppose. I hope. I will just have to see how they go. I'll turn those on later when they're all connected. My camera at the moment is a Mobius, standard lens, not the wide angle one that adds a lot of distortion to the image. It's on the Taro 2-axis 2D gimbal sold by Hobby King. This gimbal is coming for a lot of stick, a lot of it is justified. It has been said that the designer of it had never seen a Mobius camera, and I am inclined to agree. Main issues are that the dimensions of this frame here means that you cannot line the centre of the camera up with a roll motor, and there's not enough room at the back for the USB connector if you balance a pitch motor. I've moved the camera slightly forward and made this lead especially to give enough clearance. It's difficult to set up to get around this mechanical out of balance. You will see that I have added weights to compensate. It does now actually and eventually stabilise and work quite nicely. But if I was buying a gimbal for a Mobius camera again, it wouldn't be this one. While we are looking at the gimbal, my shortened legs are 110mm. I have still got plenty of space here, so I'm okay. I'm working on a gimbal for my Nikon V1, which is a lot bigger camera, obviously, and I am planning to mount it higher, as I would still like to keep these legs. But hey, if I have to get some more machined a little bit longer or taller, then so be it. Right, let's have a look under the rest of it. You can see I am using the Futaba R2008 SB receiver, and this is the antenna mount I was telling you about earlier. Connections. I'm using S-bus into the DJI NASA controller. I've got a single wire out here giving me PWM from channel 5, which provides my manual camera pitch. From a VR knob I've got on the transmitter. And finally I've got the 3 wires which are the connections for the light switch, which I was talking about earlier. These are PWM, standard PWM on channel 8. I use this big 10 amp hour 4S battery. It's heavy, but the power of a 3515 motors is more than sufficient to carry it. With a 4S 3300 mAh battery, Multi-Rotor eCalc, which is a brilliant tool by the way, said I have a payload on this rig of about 5 kilos, so sticking this bigger battery on has hardly made any difference at all. Nothing else to see underneath, I'll stick it back down. And I think this covers the lower part of the frame. To quickly recap, I've got the 4 Emax 3515s, the red Taro stronger fixings, my 30 amp Opto ESCs, the modified light switch unit, my own distribution board, everything on it. And here's my board with the side navigation lights on. The power cables here go to the top deck, to the NASA power supply unit. I've got a bit buried down here the camera's video signals that go up to the OSD and then the AV transmitter. I've got my 4 ESC signal connectors that also go up to the NASA controller. And this is the S-bus lead from the receiver, again up to the NASA controller. And so to the top deck. At the risk of repeating myself, I really like this Alien 560 design because of this lower and upper deck arrangement. It allows me to have all my electronics on the top and all my power on the bottom. Right, so where shall we start? Let's start at the back. The A560 has got as standard this nice raised platform to put the GPS on, which I imagine works, but for cosmetic purposes and because it helps orientation when it's flying and to get the GPS receiver away from anything electrical which might produce interference and affect its accuracy. I've put it on one of these hinge-up masts. The fact that I've got the GPS that distance behind the NASA and the distance higher than the NASA isn't a problem, as when you configure the controller you put in these dimensions so the controller knows exactly where it is in comparison with the GPS signal. Okay, admittedly it's only 100mm here or there, but you have GPS, you may as well go for the best accuracy you can. The NASA Light Flight Controller, which I'm sure most of you are familiar with, I bought this as a light and upgraded the firmware and got the £200 much improved version 4.02. My upgrade went through perfectly, no problems at all. I hear in the forums some people have had problems, but there again hundreds of others haven't, so I think it is pretty well tried and tested now. The important thing to remember though is that if you do this afterwards, when you are prompted to do further updates from the DJI website, don't do them, as I'm reliably informed that if you do it will lock it out and then you have to do a complete reset right from the very start. Let's move forward a bit. I have got, sorry I can't remember which make this video transmitter is. It's nothing special, just one of the standards at 200 milliwatts. I use these cloverleaf antennas. You can get these from Radio C for only about £7 a pair. It's a plug here for Radio C in the UK. Excellent company, service second to none, very helpful. Yes, they're great, and you don't have to pay import duty and VAT and all the other stuff you get with so-called cheap China bits, which by the time they get to your doorstep is not actually any cheaper. I'm using this DJI OSD unit. It works quite nicely. The only annoying thing is that my battery level icon on my receiver monitor half covers up the satellite display on this, and I can't reposition either of them. But never mind, we can live with that. I have also got the DJI, bit of a mouthful, little Bluetooth adapter here. It's great for making changes without having to plug into the laptop all the time. Using a smartphone app, you can do almost anything while it is unarmed, and when it is armed, you can change its pitch settings, which is pretty useful if you're out flying and you want to tweak them a bit. This Bluetooth and OSD runs off a CAN bus, so you need to have the NASA V2 PMU power supply. As I said before, I bought my NASA part as the light combo kit, so I just got the basic power supply originally, but to buy one of these for 25 quid was worth it. And that is my top deck. And as I sort of mentioned before, the only connections I've got here are my camera, my LiPo voltage coming into the power supply, this one here is the 12 volt power for the AV transmitter, and then I just have to plug in my 4 connectors from the ESCs. If you're wondering what all these little green things are on the top deck, they are a sort of cheap wire staple made from PVC covered solid wire, and I just use them for keeping and routing all my cables nicely in place. You could use cable ties, but these take up less space. I think I used a 1.2mm drill and they go through nicely. I suppose one day I'll change them to black wire, but at the moment the green looks nice enough. While I'm talking about routing cables and keeping them nice and neat, one thing I have noticed on this design is because the height between the top and the bottom of the deck is probably only about 25mm, and I've got the bottom deck, which I call the tray, fairly full, and underneath I've got the power supply sticking out. When I do come to fix it together, it does get rather tight. So whilst in some places I have wires twisted, with others I've just kept them together with hoops of heat shrink. This keeps all things nice, slim and flexible, and if I carefully lay these in the gaps when I bring it together, it does actually fit nicely. Okay, let's put it all together and we'll see what it looks like in all its glory with props, etc. And here we are, back with it now all screwed together. Internal connections are made between the upper and lower deck, props are fitted. In case anybody was wondering what these 4 posts sticking up here with nothing on them are, I screw this little plate on, then I can either put on a GPS GPS tracker unit, not that I've lost it that far yet, or sometimes I borrow my mate's GoPro, which I put on top just to give me a different filming aspect, so you can see the front of the quad as it flies through the sky. Here also I've got my 4 ASCs connected. To make life easier, I just number them 1, 2, 3, 4 using cable markers. All instructions tell you that you need to have the flight controller slightly insulated from the frame because of vibration, and so I have mounted it on this plate with rubber bobbins like what you would use on gimbals. But it is actually quite soft, and I read somewhere that whilst you have to insulate it, if you don't have to insulate it too much, and I wonder if this is a bit too much. So if anyone out there has any experience with what the problems are with an over anti-vibrated controller, please just pop me a note. I'll be very pleased to hear from you. As you can see, I use carbon fibre props and what is called a T-mount. I love these actually because the centre hole of a prop is a really nice fit on the motor spindle, which means it holds it really centred, and you have 2 screws with a clamp disc holding it down really nice and firm. No worries about clockwise and anti-clockwise motor threads. I balance all my props with this Dupro balancer. I must say that all the props I have bought have been very good and have only needed a small tweak here and there. Right, let's power it up and see if this gimbal I've been talking about stabilises nicely. I'm using this big 10 amp hour battery underneath with the XT90 I was talking about. Right, and maybe this has started recording. It looks like I've got my pitch control down on my transmitter. There we go, that brings it up nicely. At the moment I have the pitch control adjusted so that when I move a transmitter knob, it moves until I turn the knob back to midpoint at a speed that's proportional to how much knob movement I've given it. It gives a nice smooth effect for filming, but I'm going to change it because I would prefer to know exactly where the camera is pointing, especially when it is horizontal. so I'll reconfigure the gimbal firmware so the knob position is relative to camera angle. My latest additions are these lights. The first flick of the transmitter switch gives me the front lights, 2 white and 2 blue in the middle for identification purposes as much as anything else. The second switch brings on the navigation lights, green on that side and it should be red on the other. Yep, it is. And then another flick turns them off. And that just about concludes what I want to show you on my Alien 560. If you have any comments, suggestions, questions, feel free just to let me know. Thanks for watching. If you did find this of interest, please like and subscribe as I plan further shorter topics videos in the future. And to finalise, here's a few slides with where I got bits, a few recommendations, and coming up there's some snapshots of the multi-rotor eCalc sheets which I use for checking my motor, propeller, ESC combinations, etc. Thank you. Bye now.